This one is called We Belong to the Universe. So this starts with the great flaring forth, the Big Bang, 13.7 billion years ago. All we had initially was hydrogen and helium as the elements. You then had star formation and galaxy formation, and it's through the life cycles of these different sizes of stars that then bring about heavier and heavier elements. So you go from, for example, hydrogen fuses to helium, which then goes to carbon, which then goes to oxygen. Depending upon the size star that you're dealing with, you go further and further up the periodic table of elements. It is only these big blue stars, the ones that are anywhere from 8 solar masses in size on up, that it will eventually go supernova. And it's in the supernova stage, then, that you have the fusing together of all of the elements represented then on the periodic table. Because of the different sizes of stars, each size of stars can go up just so far. So for example, our sun will only be able to go to carbon. If you had something that was maybe 2 sizes the size of our sun, it might go all the way up to oxygen. Stars that are like 8 sizes of our sun can go all the way up to magnesium. But then as soon as you hit right around 8 solar masses in size, you go to iron, the star collapses and then goes supernova. So that's kind of the overview of the life cycles of stars. And it took all kinds of stars going through those life cycles to eventually, about 5 billion years ago, between 4.6 and 5 billion years ago, there was a supernova explosion in our part of the Milky Way galaxy, which spun off a new little sun with enough heavy elements circulating it that rocky planets, as well as gaseous, but certainly rocky planets, could then form. And one of those rocky planets, of course, that emerged is Earth. And so seen from outer space, looking back at Earth, this is our emergence story. It took 9 billion years of star evolution for Earth to emerge, but it didn't look like that 4.5 billion years ago. Instead, if you were out in space taking pictures of the surface of the planet, this is the story of the last 4.5 billion years leading to today. And each one of those views of Earth has a story that science has given us as to why it would be that color. So you've got molten planet, crustal material, a crust forming on the top. The rains then came, and for 2 billion years we were basically a water planet, but we were kind of this pea soup green color because of all the dissolved iron in that water. And there were a lot of photosynthetic, single-cell photosynthetic life forms around. And eventually they pumped so much oxygen into the water that the iron in the water literally rusted and precipitated out, fell to the bottom, and that formed many of the banded iron formations that are mined today. And when that precipitation occurred, the oceans, you might say, cleared. They stopped being that same green color, but you still had carbon dioxide atmosphere, so it was still a bit murky if you were taking pictures out here. And it wasn't until about 1.5 billion years ago that there was enough oxygen being pumped into the atmosphere itself to dilute the carbon dioxide that gives us then this beautiful blue color that we see when we take a picture from space. During this time period, you had a lot of well, you've always had tectonic plate movement, but you had then the birthing and the dying of various continental forms. You had Rodinia was the one that was being formed in this time period right in here. Rodinia took up about 1/4 of the surface of the planet and moved to a spot where the circulation of the oceans were affected such that the planet froze over into what is called snowball Earth. This was about 700 million years ago, and it lasted for anywhere from 50 to 100 million years is the best guess. And following that, there was, again, always volcanic activity. In this case, it broke the ice shield, you might say. And the Cambrian explosion of life, what we call the Cambrian explosion of life, occurred right around 550 million years ago. And then that whole time period just fits into this little tiny time frame right here, which is usually the one, that's the time period that you see anytime you go into a museum and they talk about a prehistoric journey. They usually start that story right about here. This little white line right here represents the ice ages, the 17 to 22 different glaciations that have happened on the planet have all happened within the last 2.5 million years. So it's a very concentrated time frame. And that was brought about probably, and there's still question, which is what you've got to love about science, is the jury is always out in terms of being open to new evidence. But as of this time, the best explanation that I've heard is that the Isthmus of Panama was closed, and again the ocean currents were stopped. The planet then began ushering in these variations of glaciations that we call our ice ages. Okay, the next story is told here. Okay, this is the last 570 million years. I'm using David Christian's break-off point for the Cambrian. So here we have the Cambrian time period, the Silurian, the Devonian. The Devonian is when the fish were beginning to come onto land. If anybody's ever read Your Inner Fish, this is the time period in which that story is told. The Carboniferous. The Carboniferous period is when you had lignin first show up, and so you had your first trees, and lignin at that point had no fungi or bacteria to break it down, and so when the trees died, they fell over and literally just did not decay. They could not decay. And so a lot of our major coal beds that we mine today are from the Carboniferous time period. Also during this time, our oxygen levels in the atmosphere were up to anywhere from 30 to 35%, and today they're only 21%. So what that was able to do is to support all kinds of gigantic life forms, like 7-foot-long millipedes, and dragonflies with wingspans of 3 to 4 feet, and all kinds of animals and insects that we're very glad that we don't have on the planet today. Following the Carboniferous period is the Permian, and this is the age of reptiles. And then you have the Great Permian Extinction, which is 250 million years ago. And that snuffed out 90 to 95% of all the species on the planet, just in that single extinction alone. And then that was followed by the Triassic, the age of dinosaurs, the Jurassic. They keep getting larger and more complex in form, and the, let's see, where are we here? There's the Triassic, the Jurassic, the Cretaceous, and then about 65 million years ago we had the asteroid that hit the Yucatan Peninsula, snuffing out all the larger forms of life, everything from the large reptiles in the oceans, to all the dinosaurs, to the great pterosaurs in our skies, all gone. 70% of all species were eliminated at this point. And then that ushered in what we call the Age of Mammals. So we could not be here if it hadn't been for that Yucatan Peninsula asteroid and a lot of other events. The next one is called We Belong with Perspective. So 5,000 years of civilization leading to today. By the way, we've increased our population size tenfold just in the last 300 years. Yeah, amazing. So everything from Stonehenge and the Great Pyramids, all the empires coming and going, leading to today, can all be fit into this period here. And then using the powers of 10, because we're talking about perspective here, using the powers of 10, here is a summary of what has happened in the last 50,000 years. which include the migrations out of Africa, going into Central Asia, going into Europe, of Homo sapiens. Then the last 500,000 years, Neanderthals were around very early in this time period. They only died off about 30,000 years ago, actually. So the various events that occurred in the last 500,000 years and the last 5 million years, which again, just bringing us back to humans, we had various hominid types. 4.4 million years ago you had Ardipithecus, then you had Australopithecus, Lucy, you had Homo habilis, Homo erectus, all kinds of hominid forms that have lots of other names that existed side by side. At one point in Africa, they assumed, they believed that there were something like 4 different varieties of hominids living within very close proximity to one another. Last 50 million years, this is when a lot of the mammals were coming about in North America, for example. Cheetah and pronghorn co-evolved. So the pronghorn that we have around here, that are very fast, and the reason that they're very fast is because cheetah was their predator. Silurian, Devonian, and so on. And then finally the last billion years, which is just before Earth and Sun was formed and Earth created. So what this tells us is our civilization represents only 1/1,000,000th of Earth's story. That's the kind of perspective that we can get from this deep time story. And then finally, this just gives us the last 360 years. This is the time period from 1650 up until today. Just gives us a sense of really the story of what has gone on here in terms of colonization, you might say, of this land is all here in this very brief section. The whole Industrial Revolution is all contained within this very brief time period. Most people's family trees would be only able to go out to this time period. So it's a very short period of time. But just to give us an appreciation of what it's taken for us each to be here, just in the last 360 years, I wanted to give you a visual of that. And remind ourselves that each one of us has 2 parents, 4 grandparents, 8 great-grandparents, 16 great-great, 32 great-great-great, 64, 128, 256, 512, get the picture, right? So just the 360 years before you were born, there were over 8,000 individuals who were your direct ancestors. So if any one of these little dots, if any one of these people hadn't lived and reproduced and so on, you could not be here in this form. So when you start talking about being surrounded by the ancestors, this kind of gives you a whole other take on what that means, about being surrounded by the ancestors. And then to bring in the future generations, which is the only reason really to be doing this work, is to be, first of all, being inspired by possibility, because that's the way we will make it through, not only make it, but thrive through. But also to be a stand for the future, is to just see each one of us as either giving birth to, or mentoring, or caring enough about another child. So if you just look at each one of us reproducing ourselves, or each couple having 2 children, 4 grandchildren, 8 great-grandchildren, 16, 32, and so on. Even if you just leave it at that small level, just imagine how many people you are responsible for by your actions, by your intentions, by your visions for the future.